Why isn't Earth perfectly round? In space photos, Earth looks like a perfect circle. So do all the other planets and stars. But in fact, our planet is far from perfect. Perfect spheres are quite rare in the universe. Let's see why. First of all, why are planets spherical at all? The answer is gravity. Planets are formed bit by bit, over very long periods of time. Bits of matter bump into each other, forming bigger clumps. The bigger the clump, the stronger its gravitational pull. It draws in ever more matter, growing in size. When it's big enough, gravity starts smoothing it out. An object's gravitational pull always points toward the center of its mass. But gravity is actually surprisingly weak. A smaller object won't lose its shape. It takes a massive object to pull rock into shape. This is why smaller objects, such as comets, aren't spherical. But Earth is certainly big enough. So why isn't it perfectly round? A good example of Earth's imperfection is Mount Chimborazo. This mountain in Ecuador is Earth's highest point. However, it's 9,000 feet shorter than Everest. That's because Mount Chimborazo sits on the equator. Earth is squished at the poles and bulges out in the middle. So Chimborazo reaches 7,000 feet farther into the sky than Everest. The shape of our planet is technically oblate. That's like a slightly flattened sphere. That's because gravity isn't the only force affecting it. There's also a little something called the centrifugal force. This force is the opposite of the gravitational pull. It's directed outward, and it's caused by Earth's rotation. You can see it in action too. If you spin around in a chair, you'll feel a pull away from your center. The same thing happens on a merry-go-round. All planets and moons spin in their orbits. So the centrifugal force causes them to bulge at their equators. The effect can be very subtle, but in some planets it's very pronounced. Good examples of this are Jupiter and Saturn. Even in photos, you can see that the gas giants are slightly squished. Their middle bulges out noticeably as well. The reason we can see it is simple. They're the fastest spinning planets in our solar system. The faster something spins, the more the centrifugal force acts on it. An extreme example of the centrifugal force is Haumea. It's a dwarf planet in the Kuiper Belt. The Kuiper Belt is a region of icy objects outside Neptune's orbit. Haumea is about the size of Pluto, but it's spinning extremely fast, one complete rotation every 4 hours. As a result, it's almost egg-shaped. Earth's shape is further distorted by mountains and ocean trenches. Some trenches are more than 36,000 feet deep. Even sea level itself is irregularly shaped. Slight variations in Earth's gravity field create hills and valleys. The ocean's surface has permanent dips of over 300 feet. Additionally, the shape of the Earth is always changing. Sometimes this change is periodic. Daily tides, for example, affect both the ocean and the crust. Sometimes, the change is slow and steady. Tectonic plates drift over millions of years. The crust rebounds after a heavy ice sheet has melted. Sometimes, the shape of the planet changes in violent episodes. Earthquakes, volcanic eruptions, or meteor strikes. So there's just no chance for Earth to stay round.